So, a quick introduction for people who didn't know me yet. My name is Tom Zick. I'm part of Bull Atos company in the big data and security brand. My team is a HPC global delivery team. So we mainly doing installation of customer cluster. We're also doing training, and we provide some expertise level to different kind of customer around the world. I'm an HPC engineer specialized in hardware and data center. And I'm here today to speak a little about hardware, especially how you will be able to show your hardware. Spoke a little about space, power, and cooling, mainly on data center aspects, and a little parts on physical deployment and maintenance of HPC cluster. To develop a little in the first part, hardware part, we will speak quickly about HPC-based, cluster-based components, calculation type, aesthetics aspects, and the feature of each HPC cluster. The second part will mainly going on the data center parts, beginning by localization, the building itself, power and cooling, room, and networks. Finally, we will speak about the site review, preparation of the installation, truck delivery and installation, cooling and power test, because it's an important part when we deliver a cluster, cabling, beginning of the cluster, starting, first usage, benchmark, and the maintenance. During this presentation, don't hesitate to interrupt me for any question. I'm here to train you. I'm here to share experience and to be sure everybody in this training will understand every aspect. So again, don't hesitate to interrupt me to ask questions. Hardware parts. First, the HPC base. What is HPC? What does it mean? HPC is all the complex calculation solution. Customers, some people will need to make a lot of complex calcul and to have a solution or part of solution of really complex problem. When we spoke about HPC, high performance computing, we also spoke about cluster, calculation cluster itself. A cluster, it's a big number of compute servers working together to resolve some coding solution. Just yeah, really big solution, and we already spoke many times about cluster, and we have to find a good way to implement it into a global solution. Ooh, a lot of people join. Calculation and analytics. Generally, people have a lot of information. For example, weather sensor, marketing information, consuming data, and wants to have statistic from it. Statistics, people information, etc. They want to use those data, big quantity of data, to obtain a solution. So the two main parts on the HPC cluster, HPC solution, it's the data and the code, the coding, the jobs. So the first part is to know how to use data, collect them, of course, how to use it, how to translate it to have some kind of answer or some kind of job to launch. We have many applications for HPC. We have mechanics like schematics, engine schematics, etc. Military usage, like, yeah, I don't know, aircraft conception, bomb, war, really, yeah, a lot of military difference application. A lot of clusters are used for financial reason. For example, to secure all the transaction, to have, yeah, some speculations markets, etc. We also find it in weather. I think it's a big usage in the world to prevent all the weather in the world. It's actually the usage of the Senegal and Ivory Coast cluster. Automobile, of course, and aerospace. Aerospace, we saw, for example, SpaceX and NASA work. They have really big cluster to be able to do it. So to resume, the customer will have code, jobs, mathematic algorithm, and we have to provide an HPC solution to be able to resolve their mathematics code. To do it, we will put in place a cluster. This cluster will contain management node, login node, compute node, storage, etc. That's the base. First of all, the compute node. The compute node is a server who will be able to resolve complex mathematic code, mathematic jobs. In a cluster, we don't have only one server, one compute, we will have a lot. And they have to work together. To be able to work together, they will have a network. This network is both. They need an internet simple network for the management and an interconnect fast network, low latency network to be able to share memory quickly. A compute node is able to have a direct access to the DIMM memory of another compute node. So they want to access to it as quick as possible, like their access to their own memory. So to be able to do it, the network is quite important. You will find a management node. The management node is to deploy and install all the compute node, managing it during all the cluster life, and be able, of course, to to connect to the cluster and on little cluster to be able to use it. Storage is an important part because like we spoke just before, you will have a lot of data, quantity of data. You will have home user environments, so you will need storage to do it. And the login node. The login node is for final user, all scientists, people who want to use the cluster to push some job on it, will going through the login node. On really little cluster, you will not have login node. The management node will get the role of login node. That is a base, cluster base, a little cluster base. In more bigger cluster, we will find a couple of more nodes. The storage will be bigger. Management node will have HA, high availability solution. Login node will be multiply. You will have 1, 2, 3 login node, depending on size of the cluster. You will have different kind of compute. You will have ARM, AMD, Intel nodes, depend of which kind of CPU jobs you have to launch on it. GPU nodes for all vectorial calcul, vectorial solution and all graphics aspects. Big memory, if you have a really, really big quantity of data to calculate in the same time. Gateway node, it's more for cluster connected to other cluster on HPC cluster on company network with remote access. So gateway server, it's mainly when you have to connect to another network and to securize this network. And Visu node, visualization node. That is mainly used when you have a GPU nodes, because the GPU nodes will calculate vector, calculate different vectorial information, but they are not able to generate a visual solution, graph, I don't know, thermical analytic, or something like this. For that, you will need a visualization node to be able to generate this visual aspect. That was for the cluster base. Did someone have any question, any remark about it? Yes?
Thank you, Tom. I'm looking at the big memory vis-a-vis in-memory computing. Is there any relationship? I'm wondering, why would you need big memory? That's number one.
Yeah.
Then number two, Intel, AMD, ARM, are there comparative advantage in selecting the processor base for the compute node? Thank you.
You're welcome. The big memory, it's quite it's quite specific. Some scientific calculation will need more memories to do some action, it's specific instruction or other. To simplify, the basics compute node on a cluster is a CPU compute node. You will have a CPU who is able to do all the job possible, and you will have a little quantity of memory, or little, almost little, because actually we mainly use more than 2000 gigabyte by node, and you will be able to do all the job possible. If you have a big quantity of memory to use for specific jobs, the compute nodes will be able to do it. But if you have big memory nodes, you will be more efficient. When I spoke about big memory, I spoke about node with 1 terabyte or 2 terabytes memory DIMM inside. So a very big quantity of memory, and it's when you have to move and I would like to say, change, calculate, evaluate a big quantity of data at the same time. So for example, when you have to, I don't know, take the temperature of all the big African city and want, I don't know, to have moyen or normal quantity, normal temperature by season during years. So you will have temperature on each hour on each big country during 1 year. It's a big quantity of data, and you want to calculate all of them in the same time. So a big memory will be useful in this case, for example. For the ARM, AMD, and Intel blade, that depends also of the calculation itself or the job itself. Some people will be able to optimize some coding some application to be launched quicker on ARM, AMD, or Intel infrastructure. I'm not quite qualified to explain that in detail. Maybe Benoit will be able to do it more precisely. But yes, it's mainly because scientists will be able to optimize. Is the answer quite okay for you? Clarify a little more?
Yeah, thank you. Thank you, Tom.
You're
We
welcome.
can move on. Let's say we have further questions.
Thanks.
Any other questions? Please, you can go on.
Yeah. So, to speak a little more about components, you will have the network parts on the cluster. The network parts will be defined in 3 different types. You will have the administration network. This network will be used to push, for example, in PXI, each image, compute images to provide some IP address with DHCP, DNS resolving, yeah, all the administration stuff. You will have interconnect network. Generally, we saw InfiniBand network, fiber network, high-speed fiber network, gigabyte network. In fact, you will need a quick network and to be able to share a big quantity of data between each compute node. In fact, this network is used for jobs. So you will be able to transfer data between the storage, for example, sensor relevance, financial information, to all the compute node. So we spoke about terabyte or petabytes of data, and you want to do it quickly. As Sam spoke just before, you will all compute node also will transfer data between memory, RAM memory. So they have to do it quickly when they're working together. So you will need a really low latency network to do it as useful as possible. For example, the InfiniBand network will have 0.001 milliseconds by transfer. It's very quick. And each compute node will have a bandwidth between 50 and 100 gigabyte by second. That's a standard standard transfers rates for interconnect network. And the last one is maybe less important, but you will find a SAS network on some cluster just to share more efficiency, the home environment with login node, the scratch with some specific nodes, visualization node, for example, or the storage for the high availability on the management node. So the SAS, it's maybe less common, less important, but could be quite useful on some solution. Of course, you have many different technology. You will have internet, SFP, SFP+, QSFP solution, SAS, and you will find copper and fiber. The both are really useful. Just taking into account that if you use copper, you will be disturbed by big electricity interferences. So it's only for short distance, but you will find actually big, really efficient technology in copper really efficient and low price. So our many cluster copper, it's quite useful. So fiber, it's for long distance in the cluster and also provide a low latency, quite efficiency. So if you have a very big cluster, if you use different room and you have to connect them together, the fiber should be really useful. That for the network part. On the compute parts, you will be able to find two really big difference between CPU and GPU parts. The cache, the DRAM, the number of core, and also the facilitate to do the same instruction a lot of time. That is a really big difference between CPU and GPU nodes. We spoke a little about the different kind of CPU, so I will maybe not do a lot on it. But for the difference on CPU and GPU parts, the GPU is more able to do the same instruction a lot of time, depend of the compared to the CPU. CPU is able to do a lot of different instruction in same time. So if you are a complex calcul, like for example in mechanical aspects, you will need to, I don't know, aerodynamic calculation. It's more useful to use a GPU because you will use vector and you will use a really big quantity of same instruction. If you have to calculate the engine aspects, mechanical aspect, explosion, efficiency, the CPU will be more useful because you will have a lot of different coding instruction, and the CPU will be more efficient. We have AMD, Intel, ARM difference. That is exactly the same than I expect. The AMD will have a lot of different core than Intel. For example, Intel processor will have 15 core or thread, and the AMD actually will be able to have more than 200 core. That is a big difference. The ARM is more efficient in power and heat, but less people developed an ARM processor. So each processor have a really different kind of usage, and scientists know it's much better than sysadmin or HPC expert, if I would like to say. The GPU is a big memory. It's exactly what I'm explained previously. So no really big difference on it. And you will have also to choose how you will evacuate all the RAM, because a processor, a GPU, or a memory DIMM will change all your power in heat in RAM. So you have to evacuate heat. The more common usage, like your computer server, it's the air cool. You will have fan to evacuate the hot air outside the computer, and you will have metal pieces on warm parts, processor, GPU, etc., to do the best exchange possible between processor, metal, and air. This hot air will going directly to the data center. So on some aspect to be more efficient, you will be able to put water door. Water door will use a cooling network like climatizer, heat exchanger, to put in the data center less warm air. So there will be in place at the rear side of the rack or the rear side of the server, just to cold a little the air before put it in the data center itself. And the more efficient solution, a little more expensive, of course, it's a direct water cooling solution. You will have a direct water cooling on the processor and GPU. So you will have really little quantity of hot warm exchange with the air. That is a more efficient solution, but more complex too, because you will have to put the exchanger on each GPU, memory DIMM for AMD processor mainly, and you will have to evacuate this water outside of the blade or of the server and exchange it somewhere else, maybe in the rack, maybe in the data center itself, but you have to manage this water. That is a three big different solution. Air and water are the main one. The water cooled door, it's mainly used when you have a big quantity of compute node in the same racks. The management node. The management node is used for services mainly. So you will have a big quantity of different services launched on it: DHCP, DNS, LDAP, PXI. On some node, you will be able to share a little storage for little cluster like Scratch, home user, etc. And of course, you have to have enough powerful network to be able to deploy the big quantity of nodes. When I spoke about big quantity on little cluster, generally you will have 200 to 500 nodes. In a big cluster, you will have 2,000 nodes. So you will have to choose correctly your management node and the capacity of the management node to be able to deploy a lot of node and to put IP address on a lot of equipment, answer to a lot of DNS question at the same time, DNS request at the same time, etc. So management node needs a big capacity depend of the cluster side. And of course, you will be able to put some kind of cluster of management node to manage big cluster. On the management node, you will also have a subnet manager. The subnet manager is for the interconnect network. When you need interconnection management, for example, on InfiniBand network, BXI network, Intel OPA network, who will be the three best solution for interconnect network. You will need a DHCP or a solution like this for Ethernet gigabit networks, fiber or another. But the subnet manager, it's more specific for InfiniBand and BXI. For little cluster, as I said just previously, the management node will also have the role of shared storage and login node. So on little cluster, you also have to take it in account. We spoke about use many management node in the same time for big cluster. To be able to do it, you will have share storage between management node. So two possible solution. Some server have some chassis blade will have two server inside. So you will have the management 1 and management 2. Each server will have its own storage, generally in RAID 1 for all the Linux parts.
Tom?
Node.
Tom? I think we lost you in the
The
last.
login node. The login node will
Tom?
be used by, yeah?
Yeah, I think we lost the connection for like 3 minutes.
Oh,
Yeah.
on which
Yes.
point?
No, this slide. Yes, this slide. Yeah.
Sorry. I will explain again. I'm spoke about the high availability services on the node. When you have many management nodes on the same cluster, they have to work together and share services for redundancy. So if they share services, they have also to share the config of their services or logs, data, etc. To be able to do it more efficiently, you have to share the storage and the first part, more efficient part, it's to have one blade with two servers inside, management 1 and management 2. You will have disk at the front. Some red one disk will be used for the operating system, Linux, and a red 5 or 6 share between the two servers for all services to share the HTTP config, DNS config database, LDAP database, and key user, etc. And another solution is to put this shared storage on the network and use the network to be able to do it. This solution is more efficient for a really big cluster because you will be able to put a server on different rack, different PDU to have more redundancy. Now, the login nodes. The login nodes will be used by the final user. So the scientist who have to put his code, his jobs on the cluster. These login nodes have a really big part of security because it's an external access to your cluster. So it's an external access to your data, maybe different customer data on some data center, different user, different brand. So the security is really important on this kind of nodes to protect the cluster and to protect the privacy of all data on it. Also, because this login node is generally exposed to a non-secure network, non-administrator network, or maybe on some case, internet network directly. So the security, it's a really important aspect on the login node. This node will also have the home user share between different scientists. On some case, they will be stored directly on the login nodes or on the shared storage somewhere on the cluster. Again, you have to take in account depending of the size of the cluster. The login node also have an access to the Scratch storage. I will speak a little more about Scratch storage, but it's the storage shared by all the compute node and also the storage where you will be able to put all the sensor or basic data used by jobs. So it's a really, really big storage, and the login node have to access to this storage, but needs a limited access to this storage. You don't want to have access to the other company, other jobs to be able to disturb the jobs by changing data used by compute node, etc. So again, be careful with the storage on the login node. The storage. The storage is a more flexible part on the cluster. It will depend on the usage of the cluster, the size of the cluster, number of users on it, and how you want to use storage on your cluster. The two main storage on the cluster is the Scratch and the home user. The home user is for all the user environments and will be stored on the login nodes for the little cluster, management node for the really little cluster, or on a specific storage, Gboard or NFS share on the cluster for more bigger cluster or more bigger number of final user. For the Scratch, it's exactly the same. The size will depend of the number of nodes on the cluster and the size of the data you will put on it. For example, you will have a symbol and a single disk array. Single solution, we have many solutions, NetApp, Cluster Store, DDN, etc. A really big number of companies will provide storage, and they will provide only one disk array, a complete rack of disk array, or many racks with a lot of quantity of disk inside. Depend of if you want some terabytes, some petabyte, or maybe in some case exabyte data storage. The data are really important and you have to take care of it because data is money on this cluster. So you will have to secure those data physically and also logically. For example, limited the access to those data from user, external network, etc. To access to those data, the home user is generally directly on the node or is available by SAS connection. So you will have SAS cable between those little Gboards, disk bay, and the login node. On some cluster, you will be able to share it with a network solution, NFS, share storage, etc. Again, for the home, you will use the administration network, not the interconnect network. The interconnect network is reserved for Scratch and compute usage. The interconnect network will mainly used by the Scratch and to transfer a really big quantity of data and really quickly. Of course, you will have a different kind of software solution to do it. The main use for cluster, HPC cluster around the world, it's a Lustre solution. It's more efficient for this kind of cluster. The more simple one, it's a NFS solution. Less powerful, but quickly put in place and really efficient. Gluster, also know, Ceph for the simply. Really big different solution and depend of the usage. Again, the storage size depend of your cluster. If you have a really big cluster with a really big quantity of final user, you will need more terabyte of data for the home storage and more petabyte of data for the Scratch storage. For example, on the Senegal cluster, we have more, we are near than petabytes data for the storage. For the software solution, we spoke about share storage software solution. So the main use it's Lustre storage, of course, NFS, Cluster, Ceph. We have a lot of different solutions. we'll be able to find a MouseFS, a lot of FS solution. We will have a mount, direct mount with a SAS storage. Again, shows your solutions. Be carefully, but the two main use is NFS and Lustre. Lustre for the scratch storage and NFS for the home user or basic storage. Of course, if you are not quite if you didn't have a lot of experience with file storage or shared storage solution, Ceph will be the easier one because it's quite a good explainer of good performances. Less performance than Lustre, but it's easier to put in place. And if you have a really little cluster and you don't want to make a brain fuck, Gluster and NFS, the two best solution and simple solution for the little infrastructure. The visualization node, it's mainly used on cluster who have GPU node because the visualization nodes contain external graphical cards. So you will be able to connect directly on this server with a screen, keyboard, etc. And the usage is to generate this kind of graphics or schematics because your scientists will push a lot of jobs, complex solution, but they want data. They want to make data visible and easy to understand for external people or non-scientist people. Of course, because some job will generate just really big sheets with a lot of data inside, and it's quite difficult to generate it in graphics or schematics. And standard compute or standard computer or compute node will take a lot of time to generate this kind of graphics solution. So the visualization node is very useful on big cluster to save some calculation time. The gateway is more used for big cluster or cluster who have external access or specific access to other cluster or other network. Is only here for security. On some cluster, the only external access point is a gateway server. For example, the gateway will be able to regulate all the connection to the login node, to the management node, or to the cluster itself directly. This is useful when you have to connect HPC cluster to another HPC cluster or scientist cluster. Yep. Little mistake on this slide. To another network, company network, to another company itself, or to another building, or to connect directly to an external access. I mean VPN or directly exposed to internet, DMZ or something like this. The gateway it's rare on cluster, but could be really useful for specific aspect. When you have to choose your hardware, you also have to choose the rack and the PDU. That's a really important part because your cluster will evolve. Your cluster have to be maintained, and you don't want to pass 1, 2, or 3 hours for a simple intervention. So the rack itself, you have to choose a rack solution who will be manageable if you want to upgrade your cluster, add some more compute node inside, more management node, extra. And of course, take care of the size of the rack. If you have a little room, a big room, the size is very important. For the PDU, it's exactly the same. You have to take care of the power consumption of each server. If you need a C19 or C13, because depending on the power consumption, you will need a different kind of plugs. If your car and going to the data center for a power problem or just to shut down or reset a server. So in some case, a manageable PDU, remote control PDU will be really, really useful. Of course, on some cluster, you want to have a power statistic on your cluster. You want to know the power consumption of your cluster, of each server, to check if you have a problem or something like this. So a manageable PDU could also provide to you some statistics, power consumption statistics. On another aspect, when you chose racks and PDU, you have to take into account if you will put power cable from the front, from the rear, from the top, or from the bottom. Or some cooling solution, you will also have pipe from the bottom. From the top, it's quite rare and quite dangerous. So also take into account when you choose a rack and PDU, if your power came from the top and the bottom, that will save you a lot of time for the maintenance, because the network and the power will take a lot of place into your rack, and you don't want to be disturbed by power cable or network cable when you change some nodes. Yeah, also take into account the aesthetics aspects. Spoke about aesthetics aspects. I will go into the aesthetic parts. Did you have some question on the previous parts?
Questions from anyone? Tom, I think no questions. Please, you can go on.
Yeah, I'm asking if someone have a question.
Okay, there is a question.
Yes, please.
Thank you for the presentation. This is not a question, but a suggestion. I think the presentation is so fast. Can you slow down, please? This is my opinion, not the other.
Yeah, no problem. Hello.
Hello? Did you get the question?
Yes, more the remark something. Just I'm ask if some parts, if you need some detail on specific parts or more explanation on some components.
Okay, there's a question.
Yes.
I would like to know what is the difference between the management node and the visualization server.
Yeah, okay. The management node will take care of all the cluster maintenance and yeah, in fact, the management node will take care of the cluster itself. So from the management node, you will be able to deploy all the different node environments. When I spoke about nodes, I'm spoke about, of course, compute node, but also other nodes. The management node will take care about storage nodes, about login nodes, visualization node, gateway. They will deploy the software on it, the different services on it. They will take care of the configuration, etc. The management node usage is to take care of the cluster itself, deploy it, manage it, take care of it. The visualization node, it's for user. The management node is for administrator. The visualization node is used by scientists, users to generate graphics, to generate graph schematics or different visual to better understand the jobs answer or the calculation end. So you will have really two different kind, two big difference between visualize and management node. The management node is here to deploy and take care of the cluster used by an administrator, and the visualization node is here to generate visual answer from your jobs and is used by scientists. Is it
Tom?
okay for this question? Yeah.
Okay, there are two questions on the chat.
Yeah.
If you can check the chat.
Yeah. On racks and PDU section.
Oh,
Okay.
I can also read it.
GUID to user, which are okay. We'll start with the visualization node. Yes, of course, the visualization node have a GUID for people who are not familiar with Linux. But again, the visualization node is used for really big cluster or cluster who have many GPU nodes inside. So you will not find a visualization node on each cluster. So if the customer wants a GUID for the user who are not familiar with Linux, is always possible to put GUID on login nodes. The login nodes, it's the basic nodes used by user, in fact. The login node is used by scientists. Generally on it, you will find a Linux because scientists generates codes and coding solution on Linux mainly. But of course, you will be able to have some login nodes in Windows, in Mac, if you prefer to use Mac OS. And you will be able to put a GUID on it for people who are not quite familiar with terminal solution. So yes, it will be on the visualization node, but it's mainly on many cases on the login nodes. And is it okay for this part, this question? I'm thinking
Okay.
yes.
Yeah, the person is supposed to respond to you.
Directly in
Yeah.
the discussion. Okay.
But Tom, it's time for tea break.
Yeah.
15 minutes break.
No
So I
problem.
think we should take a break now for 15 minutes
Yeah, according to
and
you.
come back
Okay.
10:20.
Yeah, okay for me.
10:30. Okay.
20? Okay, let's go
So by
for 20.
10:30. So
Okay for
I
me.
think when we come back, we have several questions from the class here and on the chat, so we can start with that.
Yeah, of course. It was my idea. Don't worry.
Thank you very much.
Let's do it.